Hi there, this is Gagandeep, and the goal of this video is to perform a data analytic exercise using any of the tools like Weka, Azure ML, etc. So let me switch over to my screen now. So the model that I've chosen to build is a telecom churn prediction model, and let's say we have a business objective that looks somewhat like this. Consider developing a telecom churn prediction model with the business goal of keeping the churn risk clients by launching an aggressive customer retention campaign. So why are we launching this retention campaign? Is that because there's a rival in the market that has introduced a cheaper sell plans, and we want to minimize the potential churners that could leave our system by rewarding them. So what kind of data are we interested to look at? So we would want to have behavioral data in high number because behavioral data has high predictive power compared to the systems data, which is fairly easy to obtain. That's why its complexity is pretty less, but behavioral data is again costly and complex to obtain. So that's what the kind of data that we ideally would want to have. Um, so the graph explains the different kinds of data and the complexities and the predictiveness. So the data set that we took is from Kaggle. It's a telecom churn data set. It has 20 variables, and out of these 20, we have the churn, which is the dependent variable, which we are interested to predict. So I did some basic exploited data analysis on this and identified these 9 variables that could be clubbed into 3 different individual variables, so that we reduce the number of features in our model. So for this part I used Python because it's fairly easy with Python to do stuff like that. And just checking whether they are null values or not, checking what are the unique values here, and this is the code where we club those 9 variables into 3 variables. And after that I exported that into a new CSV file called compact CSV. As you can see, we have 13 columns compared to 20. So some plots that would stand out, I would say one of these, because the count plot for the churn variable, as you can see, there's a highly class imbalance problem here, because we got around 2800 of non-churners compared to some 483 churners. So there's a steep imbalance problem here. So we need to address this, because we need to keep this in mind when we are building the model, because this could lead to overfitting. I've done some basic count plots for the variables, but nothing really stands out. There's a correlation plot as well, um, that gives the correlation between the variables. Nothing stands out here as well. Let's the fairly common plots, the total hours versus charge, linear regression, that's quite predictable. And let's quickly jump into Weka, where I've imported the data already. As you can see, I mentioned that we had only 483 of the churner data, but as you can see, the count has gone up to 966, and that's because I've applied something called an oversampling technique. It's called SMOT, synthetic minority oversampling technique. What it does, it identifies the minority, and it uses a nearest neighbors to it, and it plots lines between them, and on each line it creates a new synthetic observations. uh, um, so in order to increase the count of your minority class. So that's what this uh, algorithm does. And when we classify, I represented it using these 3 models: the J48, random forest, and naive bayes. The J48 has a very good accuracy, but uh, it has classified 259 churned customers as non-churners, and that's an issue, because we are interested to have this number in low. This number needs to go down, and the metric that we are interested is the recall for the true. So it's a 0.732 right now, and if you look at random forest, it's 0.711. So it's just a little worse compared to J48. and naive base is much worse compared to these two. It's 0.563, and the what do you call, the accuracy is not that good as well. So for this, out of these three, we could say J48 did better, but let's apply uh, cost sensitive learning on this and see what we come up with. So this classifier, cost sensitive classifier, I have given J48 as a classifier to this model, and we can mention the cost metrics as well. So in cost metrics, basically these are weights that tell the model, you're gonna get penalized by this amount. Zero for true positive, true negative, because you don't want to penalize your model for doing a perfect job. But when it comes to false positives and false negatives, particularly we're interested in false negatives, I increased the weight here. So I increased it on 3 levels. For the first one, I increased it to 3 here, and we got far better recall, 8 to 3 compared to the tree model. When the weight has gone up to 3.5, the model did much better in terms of recall. And finally, when I increased it to 5, it did much better. So the count from 259 has gone down to 157. But the trade-off that we should be open to accept, that you will be getting more of the false positives, as well as the accuracy is certain to go down to some extent. So this is kind of the metric that we're interested in to optimize, but the accuracy and the precision, we would need to compromise on those because of our business needs. So ultimately, in what context uh, we are building the model, and on what metric are we optimizing it, really matters. So that's all for this video, and thank you so much.